Okay, continuing with section 6.3 on exponential functions, our exploration that we just did leads us to these generalizations about the exponential function, these properties. It takes this format: f of x equals a to the x power, where a is a number greater than 1. The domain is the set of all real numbers, or negative infinity to positive infinity, using interval notation. We saw that the range was the set of positive real numbers. So the positives are, 0 isn't a positive number, 0 doesn't get a sign, but we get as close to it as possible. So 0 with an open interval to positive infinity using interval notation. There are how many x-intercepts? There were none, or 0. I'll put no x-intercepts. You can put 0 if you like. And the y-intercept for both of them was the same, right? It was the point 0, 1. The x-axis, whose equation was y equals 0, is a horizontal asymptote as x approaches. So which way are we going as we get to get closer and closer to the x-axis? We're going to negative infinity, right? As x approaches negative infinity, we get closer and closer and closer to this horizontal asymptote. Okay, f of x equals a to the x, where a is greater than 1, is an increasing or decreasing function? We said it was increasing, right? As x gets bigger, what's happening to y? It increases. Okay, the graph of f contains the points. Okay, we know it has that point 0, 1. They both had that point. But they also have another thing in common. Notice on the one that was 2 to the x, we had the point 1, 2. And it was 3 to the x, we had the point 1, 3. So 1a was on both of those graphs. Likewise, when we had 2 to the x, at negative 1, we had negative 1, 1 over 2. And for g of x, it was negative 1, 1 over 3. So it's negative 1, 1 over a. Okay? And this figure is smooth and continuous with no corners or gaps. So in general, this is our function, our f of x equals a to the x, where a is a positive number greater than 1. Okay, another conclusion we want to draw here is this. An exponential function is a function of the form f of x equals c times a to the x. So we could have some constant out here. For our two examples, c was 1, but we could have some other number where a is greater than 0, a is not equal to 1, and c is not equal to 0. The base, a, so we call a the base of an exponential, right? We have the base of the exponent. The base a is the growth factor. I mentioned that before. Growth factor. And c is what we call the initial value. C is the initial value. Okay.